Imagine a fighter plane that its own pilots were afraid to fly, a machine that killed more of its own during tests than the enemy did in combat. They called it a flying coffin and a suicide contract. Engineers prayed it would just get off the ground, and mechanics stood around with fire extinguishers, not to save it from the enemy, but from its own design. It seemed the greatest failure of British genius, an expensive toy doomed to the scrap heap. But what if I told you that this very plane, this walking nightmare, saved Britain from a new aerial catastrophe? That it was feared not only by English pilots, by elite German tank crews who saw it as their chief executioner, and that the most terrifying fighter in Royal Air Force history accidentally invented a new kind of warfare. In this video is the story of a paradox, the story of how monstrous flaws turned into crushing advantages, how an engineering miscalculation spawned a weapon that changed the course of the largest amphibious operation in history. You will learn what devilish ritual pilots had to perform just to start the engine, and why every morning for them was a game of Russian roulette. What invisible killer would quietly seep into the cockpit and switch off pilots' consciousness mid-flight, sending them to a certain death without a single enemy shot fired? What automobile-style part in the design turned the cockpit into a deadly trap impossible to escape from in a critical second? And how all this terrifying legacy was turned against the enemy with such fury that the Wehrmacht command was rendered utterly powerless. This isn't a tale of a perfect weapon. It's the story of how desperation, stubbornness, and one crazy idea turned everything on its head. Ready to find out how the shame of the RAF became its greatest secret trump card? Then watch till the end. Dawn on a British airfield, 1942. But there's no usual pre-combat bustle here. Instead, an oppressive silence, broken only by the nervous steps of mechanics. They stand around the newest fighter with fire extinguishers at the ready, and the pilot in the cockpit isn't looking at the sky to meet the enemy. He's staring at the instrument panel, fighting an inner tremor. In a moment, he'll press the starter button, and this machine will either tear into the sky or envelop him in a deadly fireball. This isn't enemy sabotage. This is a routine morning, and the plane the pilots have already nicknamed the Flying Coffin bears the proud name Hawker Typhoon. England at that time desperately needed a miracle. The air war was taking a threatening turn. The old, reliable Hurricanes could no longer match the new German machines that appeared as if from nowhere, becoming faster and more advanced by the day. British command understood. Without complete air superiority over the English Channel, any plans for a counterstrike and the liberation of Europe would remain on paper. A breakthrough was needed. They needed a fighter capable of reaching a completely fantastic speed for the time, over 800 kilometers per hour. This seemingly impossible task was taken on by the legendary aircraft designer Sidney Cam. His plan was bold and brilliant. Take the reliable Hurricane design as base and turn it into a speed monster. But for such a leap, a heart of unprecedented power was needed, and it was found: the Napier Sabre engine. It was a masterpiece of engineering, 24 cylinders combined into a compact unit, delivering a staggering 2,500 horsepower, doubling any contemporary equivalent. On the drawing boards, an absolute weapon was born. To harness the Sabre's power, they fitted the plane with the world's largest fighter propeller, with blades over 4 meters in diameter. The armament was also awe-inspiring: 12 Browning machine guns, ready to stitch the sky with lead.
When the first prototype left the runway in 1940, the excitement was boundless. The machine flew at an unthinkable speed, easily outpacing anything the Allies had. Victory seemed within grasp. But behind the dazzling power of this steel falcon lurked a shadow. The unbridled force of its engine concealed a monstrous flaw which no one yet suspected. The first cracks in the perfect image of the future savior were already ominously appearing in the metal, and very soon they would reveal themselves in the sky with frightening clarity.
That shadow caught up with the Typhoon during one of its routine test flights. At the controls was Chief Test Pilot Philip Lucas, a man who had seen everything in the sky. He was performing standard maneuvers when suddenly the plane shook with such force it was as if invisible giants were trying to tear it apart. The controls went numb, the machine stopped responding. Looking back, Lucas saw something that chilled his blood. The tail section of the fighter began to tear away right in mid-flight. Metal groaned, rivets flew out of the structure like bullets. It seemed one more moment and the plane would snap in half at a dizzying height. What happened next can only be called a miracle, forged from steely composure and supreme skill. Lucas didn't panic. Instead, he began an incredibly risky and delicate dance with death. Gently, balancing on the very edge of a stall, he began to reduce speed, trying to keep the disintegrating machine from final breakup. Every second could be the last. The ground approached relentlessly, the tail holding on literally by a thread. The landing was hard, but the plane, and most importantly, the pilot, survived. For this unprecedented feat, Philip Lucas was awarded the George Cross, the highest award for bravery. The designers, in shock, urgently got to work. Blueprints were revised, calculations checked, and the tail section was reinforced with additional elements. The main problem seemed solved. A year later, in 1941, the updated Typhoons began arriving at combat units. The first to convert to them was the Royal Air Force's 56th Squadron. The pilots, saying goodbye to their obsolete Hurricanes, were full of enthusiasm and burning with desire to show the Germans the might of British technology. However, they were in for a disappointment no one could have foreseen. The squadron's first combat morning didn't begin with the roar of engines calling to the sky, but with a grim briefing on the ground. Mechanics began explaining to the newcomers the startup procedure for the Napier Sabre engine, and with every word, the pilot's enthusiasm melted like morning mist, replaced by a soul-chilling premonition. It turned out that before meeting the enemy, they had to win their own, much stranger and more dangerous battle every day, a battle with a machine that seemed not to want to be flown. This procedure resembled a ritual for summoning an ancient, capricious spirit more than starting an aircraft engine. Instead of a simple button, the pilot had to use two special cartridges, like large shotgun shells. Their explosion inside the mechanism was meant to kick the massive assembly of giant pistons into motion. Timing and fuel mixture were critical down to the millisecond. The slightest error, and instead of the engine's roar, the pilot was met by a fountain of flame shooting straight from the engine and engulfing the cockpit. The engine was incredibly finicky about the weather. In cold or heat, it could simply refuse to start, no matter how many cartridges you used. The fate of one fearless officer who arrived at the base with a reputation as an ace illustrates this danger. Seeing the fire extinguishers placed around the Typhoons, he just smirked, considering it excessive overcaution. He confidently took his place in the cockpit, gave the start command, and a moment later found himself in the epicenter of a raging fire.
He miraculously managed to get out, but severe burns forever changed his attitude towards unnecessary measures. There were dozens of such cases. Every morning became a lottery, either the roar of an engine or a blast of fire. But even a successful takeoff didn't guarantee a return. Despite all the modifications, the tails continued to fail treacherously. Once, newcomers on the airfield, waiting their turn for a sortie, witnessed a chilling sight. A Typhoon on a training flight suddenly went into an unnatural spiral. A cracking sound came from above, and the horrified onlookers saw the tail section detach from the fuselage. The lifeless machine plummeted down like a stone, leaving a fireball and a cloud of black smoke on the ground. The pilot didn't stand a chance. And the most insidious threat was invisible. Carbon monoxide from the engine began to seep into the cockpit through microscopic gaps in the structure. Slowly, without panic or understanding of what was happening, pilots lost consciousness right at the controls. Their planes would go into a dive and crash, and the cause remained a mystery for a long time, blamed on stress or error. The accumulation of problems reached a critical mass. The Typhoon's reputation was hopelessly ruined. Experienced pilots flatly refused to switch to these flying coffins, and the command wrestled with the dilemma: should they continue producing a machine that killed its own faster than the enemy? It seemed the ambitious project was doomed to ignominious oblivion. But it was at this very moment, when patience had run out, that fate prepared an unexpected turn for the rejected fighter. A new lightning-fast threat appeared on the horizon, forcing the British to remember the fastest, albeit most dangerous, weapon they had. That threat bore the name Focke-Wulf 190. Appearing in the skies in 1941, this German fighter overturned all notions of air warfare. It surpassed the best British Spitfires in practically everything: speed, maneuverability, climb rate, and firepower. An encounter with it for a British pilot most often ended tragically. The Germans, sensing superiority, returned to their daring tactic of high-speed raids. Their Focke-Wulfs would cross the channel at low level, deliver a crushing blow to targets, and escape back at a speed nothing could match. The Spitfires and Hurricanes were left helplessly behind, watching the enemy disappear over the horizon. Alarm spread through the Royal Air Force headquarters. The air superiority over the channel, won with such difficulty, hung by a thread. An urgent solution was needed, and there were no alternatives. They remembered the forgotten, shame-ridden Typhoons, the only machines whose speed could somehow compare with the Germans. It was a desperate, almost insane gamble. The first attempts to throw them against the Focke-Wulfs in dogfights ended in failure. The technical problems were still there, and its flight characteristics at medium altitudes were unsuitable for maneuverable combat. But there was no way back. Engineers frantically carried out the final, most essential modifications. The ill-fated car door cockpit canopy was finally replaced with a proper sliding hood that could be jettisoned with one motion. All pilots were supplied with oxygen masks to put an end to the carbon monoxide threat once and for all. Startup procedures were drilled to automatism, and most importantly, control of these temperamental machines was now entrusted only to the chosen ones, aces with steel nerves and immense experience, capable of squeezing the maximum out of the Typhoon without letting it kill them. A tactic of genius simplicity was developed. The Typhoons were dispersed along the south coast. The calculation was based on exhaustion. German fighters spent fuel breaking through to the target, on the attack itself, and on the return leg, over the very middle of the channel, they were most vulnerable. That's exactly where the British interceptors lay in wait. The plan worked. The powerful Typhoons caught the returning Focke-Wulfs where they had nowhere to go. The waters of the English Channel began to swallow the wreckage of German machines. The high-speed raids, which had recently seemed unstoppable, turned into suicide missions for the Luftwaffe and were soon abandoned. The Typhoon had finally found its role, proving it could be a formidable defender of the skies. But this was only the beginning of its true transformation. Fate was preparing its evolution from a problematic interceptor into something completely different. And the starting point was a bold thought that came to a 23-year-old squadron commander who looked at his winged charge from a completely different angle.
It was at this moment of critical necessity for the Typhoon that a man was found who saw it not as a failed project, but as untapped potential. Squadron leader Dennis Crowley Milling, at 23, possessing a rare mix of boldness and an analytical mind, asked a simple but revolutionary question. Why try to remake a machine that loses in an aerial duel when you could use its one undeniable advantage, monstrous speed and power, in a completely different arena? His idea was simultaneously simple and brilliant: to turn the speed fighter into a lightning-fast ground attack aircraft capable of delivering pinpoint strikes against ground targets where slow bombers were vulnerable and ordinary fighters weren't strong enough. The very first trial sorties with bombs slung under the wings stirred up the command. The Typhoons, like heavy but incredibly fast falcons, raced over the waves of the Channel at low level, remaining invisible to German radar. Reaching the French coast, they unleashed their load on pre-reconnoitered targets, railway junctions, fuel depots, small bridges, and vanished even before the first bursts of anti-aircraft shells appeared in the sky. Losses were minimal, the effect tactically significant. However, the real turning point, forever changing the fate of the aircraft and the very concept of tactical aviation, was still ahead. It arrived with a new weapon: unguided rockets. Engineers adapted rails for 8 such rockets under the Typhoon's wings. The results of the first tests stunned even seasoned military men. The salvo of just one fighter carried destructive power comparable to a naval artillery broadside. Heavy, poorly armored tops of tanks, locomotives, fortified buildings, all were defenseless against the impact of a 60-pound rocket with a shaped charge warhead. In parallel, the standard machine gun armament was replaced by 4 20mm Hispano automatic cannons, their barrels spewing a hail of heavy shells capable of tearing through light armor and wiping out infantry. Thus, within a matter of months, an amazing metamorphosis occurred. The Hawker Typhoon, so recently a symbol of engineering miscalculation and pilot despair, was reborn. It was no longer just a fighter. It became something fundamentally new: a flying arsenal, a universal strike platform, the world's first true fighter-bomber. Its element became not altitude, but the deck, extremely low altitude, where its speed made it elusive and its firepower lethal. The plane had finally found its unique specialization, its niche where it had no equal. And as if fate itself confirmed the correctness of this choice, the Typhoon's acquisition of new strength perfectly coincided with the start of preparations for the greatest amphibious operation in history, the Allied landing in Normandy. For its success, a titanic task had to be solved: to isolate the future bridgehead by paralyzing the German defense, logistics, and communication systems, and to do so as covertly and precisely as possible. What was needed wasn't a mass raid, but surgical precision work, and the Allied command now had the perfect tool for it, honed in previous raids.
The Typhoons were to move from pinpoint strikes to conducting a large-scale, meticulously planned operation to disorganize the entire German rear in northern France. Their role was not to fight in loud air battles, but to invisibly and methodically clear the path to victory, becoming the chief sappers of the sky on the eve of D-Day.
The plan for Operation Overlord was a titanic puzzle where every piece had to fall into place. One of the most critical tasks was blinding the German air defense. Along the coast of northern France, the Germans had built a dense network of radar stations capable of detecting the Allied armada tens of miles away. These eyes had to be torn out, precisely, mercilessly, and in such a way that the enemy had neither time nor opportunity to restore them by the time of the landing. This mission of paramount importance fell to the wings of the Typhoon squadrons. Their tactics were honed to virtuosity, becoming the embodiment of speed and surprise. Groups of fighter bombers would cross the channel at an altitude literally skimming the wave crests. This flying, with the sea seeming just meters below the fuselage, required incredible concentration and skill from the pilots. The slightest mistake led to a fatal outcome, but in return, they became invisible to enemy radars, whose sight was limited by the horizon line. The Germans didn't see the threat approaching until the very last moment. Reaching the coast, the Typhoons would execute their signature maneuver, a sharp climb followed by an almost vertical dive onto the target. With the deafening roar of the engine and the whistle of split air, they would plummet onto radar towers, anti-aircraft batteries, and communication hubs. Both rockets and heavy cannons were used. The accuracy of strikes delivered from such close range was unprecedented. Where ordinary bombers dropped tons of explosives over an area, the Typhoons acted like snipers, destroying critically important equipment with one precise shot. Dozens of stations were turned into smoking ruins within weeks, and the German air defense in Normandy was deaf and blind by the start of the landings. The next phase of the operation was the methodical destruction of everything that allowed the enemy to maneuver reserves. The Typhoons switched to transport infrastructure. They became the nightmare of German logisticians. Railway trains, especially locomotives, were their favorite target. A rocket piercing the boiler would cause a monstrous explosion, shredding the entire train. Bridges collapsed under a hail of shells. Marshalling yards turned into piles of twisted rails and carriages. Roads were patrolled continuously. Any spotted column of trucks, armored vehicles, or carts was immediately subjected to relentless attack. The Allies built an invisible but impassable air barrier over northern France, isolating the region from the rest of the occupied territory. The results of this titanic work became obvious on the fateful morning of June 6, 1944. When the first landing craft were plowing the waves of Normandy, the German command found itself in an information vacuum. Their radars were silent, reports from the coast came with monstrous delay, and orders to deploy reserves ran into destroyed bridges and bombed-out roads. The famous tank divisions, which were supposed to throw the Allies back into the sea in the first hours, got stuck deep inland, losing equipment and men still on the march under continuous air attacks. The success of the landing was forged to a significant degree in the previous months by the steel wings of the Typhoons. However, after the beachhead was secured, a new, no less cruel phase of the war began, the slow, bloody advance inland through France. The Germans, recovering from the initial shock, threw their best elite units into counterattacks, including heavy SS Panzer divisions. And it was then, in a clash with the Wehrmacht's most formidable ground force, that the Typhoons were to face their ultimate test and finally prove that their transformation into a flying arsenal was not a fluke, but a prophetic vision of the future of warfare.
Faced with fierce German counterattacks, the Allies felt the full might of the Wehrmacht's armored fists, the heavy Tiger and Panther tanks, before which their own armor trembled. It was at this critical moment that the Typhoons revealed themselves in a new, even fearsome guise, as peerless tank hunters. The pilots quickly learned the vulnerable spots of these steel monsters, the relatively thin top armor of the engine compartment and hull roof. Carrying a deadly load of rockets and heavy shells, the Typhoons would dive on tank columns. One precise rocket hit to the engine bay or a penetrating hit through the side could cause a catastrophic internal explosion, turning the formidable machine into a blazing torch. German tank crews, accustomed to dominating the ground, found themselves in a terrifying trap, unable to hide from attacks raining down from the sky. The apotheosis of this destructive work was the rout of German troops in the so-called Falaise Pocket in August 1944. Surrounded German divisions, trying to break out of the encirclement, concentrated on narrow roads, creating a target of incredible density. A veritable steel storm broke over this concentration of men and machinery. Typhoon squadrons worked like a conveyor belt of death, flying wave after wave of sorties from dawn till dusk. They returned to base only for emergency refueling and rearming before rushing back into the fray. Roads became cemeteries of burned-out vehicles, fields littered with debris. Their contribution to one of the most crushing disasters for the Wehrmacht on the Western Front cannot be overstated. They became the main hammer that broke the armored anvil of the German army. With the end of the war in Europe in May 1945, the rapid career of the Typhoon ended just as abruptly. The era of piston-engined aircraft was already giving way to jets, and the squadrons that so recently been the scourge of the enemy were quietly disbanded. Planes were sent for scrap, abandoned on deserted airfields. Only a few survived to take places of honor in museums as silent witnesses to their paradoxical fate. And this fate is truly unique. The Hawker Typhoon, created as a high-altitude interceptor, failed miserably in that role, nearly burying its reputation. But, rejected, it was rethought and found its true calling, carrying out quiet revolution. It became the prototype of the modern multi-role combat aircraft, proving that one machine can be a formidable fighter, a precise attack aircraft, and a tank hunter. It laid the fundamental concept of the universal strike complex that remains the basis of tactical aviation to this day. Therefore, the story of the Typhoon is not the story of a flawless weapon that came off the drawing board perfect. It is a story of stubbornness, adaptation, and brilliant improvisation. It's a lesson that even the most problematic tool can become key to victory if you have the courage to abandon the initial concept, look at it from a different angle, and find that unique application where its flaws turn into virtues and brute force into devastating skill. It went from the shameful nickname Flying Coffin to the unofficial but deserved title of one of the saviors of the Normandy coast, leaving behind not just the memory of a machine, but a whole philosophy of tactical transformation.